Hello, my name is Gabriela, and the title of my experiment is the effects of glow germ accumulation from porous and non-porous surfaces to the skin. The purpose of this experiment is to answer the question of which surface transmits the most amount of glow germ powder to the skin. The kinds of surface tested were porous and non-porous surfaces. The area which the pathogen was applied to was the researcher's hands covered in a powder-free latex glove. The independent variables were the porous and non-porous surfaces, and the dependent variable was the glow germ spots accumulated onto the hand. The hypothesis stated if glow germ powder is put on both porous and non-porous surfaces and then pressed up against the skin, then the porous material will transmit the least amount of glow germ because the porous surface will absorb the glow germ before in contact with the skin. Glow germ is what is known as a pathogen. A pathogen replicates what real bacteria looks like on certain surfaces. In this case, when applied to a surface, a black light must be raised over the area of application for the pathogen to illuminate and light up on your skin. The glow germ is used in many scientific colleges to further understand what a germ does, but in a safer manner. The fomites are what the pathogen is placed on, such as certain surfaces. There are two kinds of pathogens in this experiment, which was completed. These are porous and non-porous surfaces. Porous has tiny holes in it coming from the word pores, and non-porous has zero openings. Examples of porous surfaces are cotton, denim, and paper, and unfinished wood. Non-porous examples are aluminum foil, finished wood, plastics, and rubber. Following is a procedure that was utilized when completing the experiment. To begin, the researcher would take a sheet of aluminum foil and spread a small amount of glow germ on it. Then they would take the glove from the hand and press it firmly onto the foil. When lifted, they would put it under the black light and count how many spots were on the hand. The researcher would repeat this until all 10 trials were completed. For the second type of fomite, the researcher would basically complete the same procedures as before, but using a cotton t-shirt instead of the aluminum foil. For sanitary reasons during COVID-19 and always, the researcher should always switch out gloves after each trial and wash your hands after every few trials. These are the chart and graph for the non-porous surface, which was aluminum foil. What the chart states is that the non-porous surface had a small amount of transmission with an average of about 5 spots. This is the chart and graph for the porous surface, which was a cotton t-shirt. This chart explains that the amount of porous surface had a much higher amount of transmission. The average was about 7 spots. Here are the mean, medians, and modes for the experiment. The mode for the number of spots collected for the porous material was 7.1 spots to be exact. The modes for the porous fomite were 8 and 6. The median for the porous surface was 7.5. The mean for the number of spots collected from the non-porous material was 4.9 spots, and the mode was 6. The median for the non-porous surface was 5.25. The following are photos from my experiment. They each show what the glove looked like with or without the black light for each surface, and some of the items needed for the experiment. In conclusion, the experiment did not support the hypothesis. This is because the averages showed that the porous surface transmitted the most amount of glow germ to the skin. A revised hypothesis could be, if glow germ powder is put on both porous and non-porous surfaces and then pressed up against the skin, then the non-porous material will transmit the least amount of glow germ because the aluminum foil will not stick to the glow germ. This represents how the hypothesis was not supported. Although the project was conducted smoothly, there were a few spots to be acted upon. When completing the experiment, it was discovered that people with skin sensitivity issues may want to find a pair of gloves without latex. Many doctors' offices have gloves without latex or powder-free latex gloves. In this experiment, there was powder-free latex gloves used. Another example was that the hand should be held down for a very short period of time, no more than 1.5 seconds. Using a stopwatch is unnecessary. This does not need to be exact, but should be close. Finally, the amount of force used for the experiment does change the results. When pressing the hand down more firmly for another trial, the results may vary. It is best to conduct experiments on the same day so the researchers remember how much force was used on that trial. The experiment that was completed is very important to society now, especially with the coronavirus spreading rapidly throughout the world. Many say that the virus is airborne, but it can also be transmitted on surfaces because of the cell's barbed edges. Adding an area rug to wood floors would likely be a preemptive step to making your household safer when encountering people who have COVID-19 symptoms. The experiment can be extended by using different variants of porous and non-porous surfaces. Some examples could be finished and unfinished wood, plastics, paper, and rubber. The researcher could conduct the same experiment, but multiple times for each foam art. This could help the researcher better understand each surface and how it is transmitted with glow germs. The following shows my log and references. Thank you for listening to my presentation. Have a wonderful rest of your day.